All right, hey everybody. So today we're talking about what is a function, and just like with so many math concepts, the ideas are built off of really specific definitions, and this idea of function is no exception. So what is a function? A function is a relation in which there is only one output coming from each input. So I use this word "from" really intentionally because output comes from input. And with a function, there can only be one output coming from an input. So if you put an input into a function, you should know for sure what's going to come back out. If you put 2 in, you should get like 5 out. Not, I put 2 in and sometimes I get 5 out and sometimes I get 10 out. You see the difference? A function is only one output possible coming from each input, okay? And for more information on relations, there's go and see another one of our videos that is 4 types of relations. So that will give you more background information on relations, okay? But a relation, just to give you the information now, a little background. A relation is a relationship that has a beginning set and an ending set. So it's very general. A function is a special kind of relation. So it's more specific than relation. This has a beginning set and an ending set, but it has very specific stipulations on what can happen when you use that beginning set. Okay, so here's some examples on the left-hand side of the board of relations that are functions. And over here on the right-hand side of the board, we have relations that are not functions. And I've tried to use some different representations here. I have a mapping in a graphical form and a table, and so that you can kind of see some different ways that functions look through different representations of mathematics. And if you want to get more information on the way that you can represent mathematics, there's another video that we have 4 representations of mathematics, so check that one out too. Okay, so here we have domain. This is a mapping right here. And we have domain and range, okay? These domain and range has so many different names that we call these things, but they all eventually mean the same thing. Domain is a set of inputs. What can you put into the relation? And a range is a set of outputs. What can come out of the relation? Okay? So also, domain, to represent an element of the domain, we use the letter X. To represent an element of the range, we use the letter Y. So this could be represented by X, could be represented by Y. Also, we call the domain the independent variable, and we call the range the dependent variable. We call the domain the set of inputs, and we call the range the set of outputs. So we have all these names for domain and range, but they all are referring to the same thing, inputs and outputs. Domain is what you can put in, range is what you can get out. So let's examine this mapping a little bit more closely. So here we have a set of inputs that we're going to put into a relation, and we'll see if it fits the definition of what a function is. Well, a function is, there can only be one output coming from each input. And at first glance, you might think, oh, this is not a function because there's 2 arrows going to 0. But let's look closely and see if it fits the definition of function. So look at 1. What this is saying is that, you see the arrow that goes from 1 to 0 is telling us that when you put 1 into this relation, 0 comes out. 1 is the input, 0 is the output. When you put 2 into this relation, 0 comes out. And when you put 3 into this relation, 2 comes out. Now we have to see, does it fit the definition of function? Is there only one output coming from each input? Well, what happens when you put 1 in? Is there only one output coming from this input? Yes, there's only one output. When you put 1 in, you get 0 for sure. Only one output. When you put 2 in, only one output. You get 0 for sure. And when you put 3 in, only one output, 2. This is a function. This is how we can tell. Now contrast this with this mapping diagram, where when you put 7 in, you get 0 out, no problem there. But when you put 10 in, you get 2 outputs coming from 10. This part of the mapping diagram right here is telling us that when you put 10 into the function, or into the relation, it's not a function, when you put 10 into the relation, sometimes you get 1 out, or you could get 2 out. That's 2 outputs coming from 1 input. It doesn't fit the definition of function, so it is not a function. Okay, let's look at this graphical form here. So a lot of people, I think, don't realize that what is shown on a graph. What is shown on the graph is pairings of inputs and outputs. Usually you see the letter X here, and you see the letter Y here. But remember that x represents an element of the domain, inputs, and y represents an element of the range, outputs. So each one of these points represents a pairing of input with output. So for example, this point right here is the point 2, 4. And if you have any trouble locating points on the coordinate plane, check out our video about locating points on the coordinate plane, okay? This is the point 2, 4, and it's called an ordered pair. And it's called an ordered pair because it's a pair of numbers and it's always in the same order, x first and y next. Well, what does x and y represent? And x and y represent an element of the domain and an element of the range. In other words, an input and an output. So here we have, the information this is telling us is, when you put 2 into the relation, 4 comes out. So from this input of 2, is there only one output? Yes, only one. When you put 2 in, only 4 comes out. Now, if there was another point here, say there was another point, this is 2, -1. Now I've just turned this into not a function anymore. Because this says when you put 2 in, you get 4 out. But this says when you put 2 in, you get -1 out. So that's 2 outputs from one input. Now it's not a function anymore. But the way it was originally, it is a function because for each of these inputs, there's only 5 inputs into this function. There's only one output. When you put -4 in, you get 1 out. When you put -2 in, you get 2 out. And so on. Now contrast this graphical form with this graphical form. So this says, what happens when you put in 2, for example? So if you put 2 into this relation, we don't know what's going to come out. Either that value is going to come out, or this value is going to come out. So this is the point, something like 2 and 1.5. I'm just kind of like estimating just to give you the idea. And this is something like, we'll call it 2 and -1.25. All right? So these 2 points on this relation, I'll take this one away so it doesn't get confusing. This point and this point are telling us this point says when you put 2 in, you get 1.5 out. But this point says when you put 2 in, you get -1.25 out. It doesn't fit the definition of what a function is because from a single input, you're getting 2 outputs, not a function. Okay, finally, let's look at some tabular forms. So here we have a table. A table is just showing the same thing that we're talking about. Inputs on the left side of the table and outputs on the right side of the table. So what happens when you put -2 in is what you get 5 out. -1 in, 6 out. Okay? And we're just checking to see, does each input only have one output? Do you know for sure what's going to come out when you put in each of these? Yes. Each of these inputs only have one output. It's a function. Now contrast that with this tabular form here. When you put -2 in, you get 5 out. No problem. When you put -1 in, you get 6 out. No problem. Then the problem happens here. When you put -1 in, you get 10 out. So this part of the table right here is telling us that when you put the input of -1 into the relation, you're not getting one output out. You're getting 2 outputs out. It doesn't fit the definition of a function. So that's why it's not a function. And so that's the end of our story on functions for today.